Alright guys, welcome back to another weekly tech tip. So last week Brett did a really great video that went into detail about the two ways that you can do Iscsi with Ceph. You've got the Red Hat way and you've got the SUSE Linux way. And then he really touched on PetaSAN and the way that PetaSAN is fantastic as a scale-out SAN. Well, in this video today, I'm going to really go in more detail specifically about PetaSAN, the features of it, how it's used, and then we'll go over to my desk and I will do an actual demo. I'll show you the administration, the UI of PetaSAN, then I'll actually do a live configuration with a vSphere cluster, and maybe if you're lucky, I'll put in a couple benchmarks as well. All right, so let's talk a little bit more in depth about PetaSAN itself. So PetaSAN has been around since about 2016 now, I think was the initial release, and they have steadily released at least 2, sometimes more, releases a year since then. And actually, we're on the cusp of a very new release of PetaSAN coming up in the next month or two, so look out for that as well. So what is different from PetaSAN to a regular Ceph deployment with CentOS or Red Hat? So the first main one is going to be that it runs on Ubuntu Linux and not CentOS. So on the note of the operating system itself being Ubuntu, it is also running Nautilus for the version of Ceph. So our current deployments in the field for our CentOS releases are also running Nautilus, although we will be upgrading in the near future to Octopus, which is the latest release of Ceph. So check out for some videos of those coming in the near future. So our PetaSAN is predominantly to be used as a SAN, and that's kind of what we use it as in our environment. It actually has other functionality as well. So where we will take it, and if a client or a customer has a use case where their first use case is something like a SAN environment for VMware or Windows, we will typically start to push them towards PetaSAN in this instance, but possibly if they have a secondary use case as well for a file system, it's great because PetaSAN actually has that functionality as well. So you can do CephFS with PetaSAN, you can do Samba in the dashboard as well, so CIFS, Active Directory joining, it also does NFS as well, so highly available NFS is part of it as well, which is great. However, the one thing that's currently lacking with PetaSAN compared to a standard Red Hat Ceph deployment is object storage. So PetaSAN does not have the Rados gateways, RGW, so you can't do S3 Swift API currently. However, that is coming in a very near release, so check out for that for sure. So one last thing about PetaSAN that's a little bit different than our CentOS deployments that we use is with CentOS we use Ansible to deploy the entire Ceph cluster, whereas with PetaSAN there's actually just a single ISO that you use and you run through a GUI installer that allows you to add your first node and then from there continuously add extra nodes all through the ISO installer. It's really cool and simple to set up. So with all that being said, I'm going to bring you over to my desk now and I'm actually going to show you PetaSAN itself. So we're going to run through the dashboard, show all the cool features that it has built in, and then also I'm going to run through that live VMware deployment that I talked about in the beginning. And then maybe we'll finish up with a few benchmarks in Windows and maybe even some Linux ones as well. So let's head over now.
Okay guys, welcome to the screen cap portion of the PetaSAN video. So today I'm going to show a run through of the PetaSAN dashboard. We can see it up here right now. I'm going to go through some of the cool features that it has. Then also I'm going to run through a configuration with a vSphere cluster. Now, for the people around that are going to be watching this that are familiar with traditional Red Hat or CentOS deployed Ceph and their regular dashboard, you will notice a lot of similarities with what PetaSAN has to offer in their dashboard. And actually, PetaSAN will have certain things that the CentOS or the Red Hat dashboard doesn't have, and then the Red Hat dashboard will also have certain things that the PetaSAN dashboard doesn't have. And that typically comes down to because PetaSAN itself is built first and foremost as a scale-out SAN. So while it still is Ceph underneath, and all of the regular things that come with Ceph does apply to PetaSAN, it is really built out for that pure use case of being a scale-out SAN that can act as back-end storage for your hypervisor environments or your virtualized environment or things like that. So the big reasons that we really like PetaSAN here is for vSphere clusters and then also Hyper-V. Now there are some other use cases for sure that PetaSAN can be great at, but those are the main ones that we really like it for here at 45 Drives. So let's just jump into the dashboard here and talk about it a bit. So I am going to be referencing the regular Ceph, CentOS, or Red Hat dashboard a lot in this. So when I say regular Ceph or traditional Ceph, know that I'm talking about CentOS, Red Hat, Ceph dashboard. It'll just make it easier. So we can see the dashboard here on the splash page. We can get an overview of our storage. We can see how many OSDs we have, how many are in and up, and then if there's any down, you would see that as well. Also, we can get an idea of our cluster health. So we can see here, just like in regular Ceph with the Ceph dashboard, you can get your health status right at a glance on the splash page. Should any alerts or any health warnings pop up, that will come here immediately. And also, just like traditional Ceph, you will have the ability to send email alerts for the event that a health warning pops up. So you can get that immediately. Now what we can also see here is our Grafana graphs, which is really nice and handy to have. So it's a little different from traditional Red Hat Ceph, but you can see here we have a drop down and we can click on different things that we'd like to see. For example, we want to click on our node statistics. We can click which node we want to view, and then we can have all different metrics here that we want to find information about. But then also we can always have our dedicated Grafana page as well. So with PetaSAN, what you do to access that is use any IP from any of your managers, except just put a /Grafana afterwards, and that will bring you right to the dedicated Grafana page, which is really handy and nice to have. So let's just go through some things. I'm not going to go through each and every setting or feature that PetaSAN has in it, but I will give you a good understanding and a good run through of all the cool things that PetaSAN has to offer in the dashboard. So we can see we can download our certificate here. So if you want to download the SSL cert and upload it to your browser so you don't get the warning each time you use the PetaSAN dashboard, then you can do that. It's really handy. We can see our EC profiles. So if you'd like to do erasure coding in your cluster and you want to use one of the defined erasure coding profiles, or if you want to create custom ones, you can do that there. And we can have our pools here. So let's click on our pools and get a view of that. It's going to be very, very similar and very familiar if you're familiar with traditional Ceph. So we can see in this cluster here we are running CephFS data, CephFS metadata, so that means we are running Ceph's file system, CephFS, and also we have a single pool here for RBD, or for Ceph's block devices called Rados block devices, or RBD. We can see we're running with a size of 2, so two-way replication, not the most recommended configuration, but for a test cluster and for a demo cluster, it's more than fine. And we've got our min size of 1, and we also do have lots of people that do run two-way replica in their cluster. It's fine as long as you know what you're getting into with it. We can see our placement group numbers, and then we can see what kind of state it's in. So if you want to do any edits, you would click here, or if you want to create a new pool, you can come in and add your new pool. And then depending on what type of pool you want, if it was erasure coding or replicated, you can make those configurations and changes here. So we can see we have some standard erasure code profiles already built, which is really nice. And then again, you can create your own custom ones as well. You select your number of PGs, although we can also turn on an autoscaler. And then we have our replicated pools, which is much simpler. So you just select your placement groups that you would like to give it. For those unfamiliar with Ceph, when Ceph creates a pool, it also creates a number of placement groups that are assigned to that pool. Now those placement groups then get dispersed throughout all of the OSDs, or object storage daemon object storage devices, or you can think of them as hard drives in your cluster. And those placement groups are just what they sound like. They're placement groups for data. And so that's how Ceph is able to keep data very evenly dispersed throughout the cluster. When a write comes in, it gets assigned to a specific placement group depending on the crush algorithm or the hashing, and that's how it works. So a very important part of Ceph, and if you didn't know, now you know. So, and then we decide which size we'd like to give it. So a 2 replica gives you 50% storage efficiency, 3 replica 33, and so on. And then if you would like to do compression or not as well. And so yeah, that's all you need to create a pool. So continuing on, crush. So this is another page I'm not going to go too in depth on. We can see our buckets tree here. So this is essentially just our failure domain of our cluster, and you can see how it's laid out. And then rules, if you'd like to create any custom crush rules. So I'll just click on it. So Ceph by default creates crush rules, and for example, you can set up a failure domain inside of Ceph, and that failure domain is typically by host or even here we can see actually it has some by rack. So you can define custom failure domains within your cluster, and that's where the crush rules come in, and it's really nice. So if you have a very large cluster that's spanned across multiple racks, you can actually set your failure domain at the rack level, or they can be arbitrary as well, which is really nice. So you can define them by, even if you wanted to do it by a HBA card, you could do that as well. So moving on, our Ceph configuration page here. So people that are used to regular Ceph will be very familiar with this page, or similar to this. Just gives you all the different tunables that are in Ceph that you can have access to, where rather than having to go and actually find the command, because Ceph has a very robust command line, you can just come in here and find the thing that you're looking for. So it's nice. You can tune it by exactly what service you're looking. So if we're looking to find an OSD, and then you can define it by basic, advanced, or development, and then we can pick and find what we're looking to do. And then if you want to change the value of it, you just have to double click on it and make a change. Very, very similar to Red Hat Ceph in this regard, but laid out a little bit differently. NUMA pinning, not very important. So if you have CPUs with different NUMA nodes, you can actually configure and pin different NUMA nodes to different OSDs. So it's a handy thing to have if you have the need for that. File systems. So as we said in the beginning, PetaSAN for us is very, very striking as a SAN first, so for block storage. But it is great that it is able to do file system as well, especially if you have a very second use case that's nowhere near as in need of the performance that the Iscsi or the SAN is, where you just need a small file system to store some files or a file server. You can do that as well, which is really nice. So we can see our file system here, and if you want to configure it and edit it or add a new file system, you can do that here. So if you wanted to create custom layouts of your file system, you can do it from this page. General settings, so this is where you would go to configure your email alerting if you'd like to do that, which is really nice to have. And then, so let's just finish up and take a look at Iscsi settings here. So Iscsi, again, this is the main reason why we use it. So we can see here our IQN, so you can pick whatever you would like to use, but this is the IQN that your initiators, or essentially the clients that are going to be using your cluster, that's the IQN that they use to connect. And now we can see we have two different subnets here for PetaSAN's Iscsi. PetaSAN does its Iscsi in a very specific way, where it splits each Iscsi LUN into two separate subnets. So it gives an IP from each subnet for the two different paths. Now you can do more than two paths if you want to. You can go upwards of 8 paths, I believe, for a single Iscsi LUN, but for most cases 2 to 4 is more than enough. And so what you do is you choose a network interface that you would like each subnet to run on your Iscsi gateways, and then from there you choose an IP range. So for this test cluster, I have a very small subnet of just 1 to 20 for both subnets. And now each time an Iscsi LUN gets created, that Iscsi LUN gets 2 IP addresses, one from each IP, which is really nice. And then, so let's say when we're adding this to vSphere, and I'll show this very shortly, all you need to do is add one IP, and vSphere will be able to find the other one via multipathing, so via dynamic pathing, which is really nice. So that's where you do your configuration for Iscsi. And then also if you're doing Samba, so if you're doing file sharing via CIFS or Samba, or NFS via NFS Ganesha, which is the highly available NFS, this is where you would configure those. But we're not going to go too into that in this walkthrough. But if there is interest in it, we can do a follow-up video. Now the next page, the nodes list. So let's take a look at this. So we can see we have 3 nodes here in the cluster. We have a disk, we have settings, and then we have logs. So we can take a look at the logs for this page and any logs that have popped up recently. You can do this from the command line as well, but it's good that you can see it here. So also, let's take a look at the settings. So we can see the settings here, and we can see the different duties that this node is running. So we can see it's running management and monitoring service. So if you're familiar with Ceph, you know the management service is it's running the dashboard here. Monitoring service is the Ceph monitor. So very, very important to Ceph. Ceph is going to want to have a cluster of monitors as well. And those Ceph monitors are going to want to remain in quorum to avoid any type of split brain happening in the cluster. So if you have a 3-node cluster, typically all 3 of those are going to be running the monitoring service. Then also we can see if it's running local storage service or not. So is it doing OSD service? And then also if you have a secondary cluster or a mirrored cluster that you're going to replicate to, you would pick which node you want to do replicating duty. This cluster is not configured in a replication, so it's not. And then also we have iSCSI, CIFS, and NFS. So if you're doing iSCSI, it's best to have at least 3 nodes handling iSCSI, and that's so if one fails, you can have all of the paths fail over to a second server rather than having it have every single path fail over to a single node. So you like to have at least 3, and I'll show the reason why that in the dashboard too. It'll make it much clearer. So yeah, we can see the duties that this node is running, and then also if we click on the nodes list again, we can go in and take a look at the disks themselves. So we can see here, this is a very, very small cluster, but what we'll notice here is that each of the OSDs that is up and running, these are 12 terabyte drives, so they show up as 10.91, and each of these is running a journal. So that means it's kind of a misnomer, but the journal is essentially the RocksDB and the wall of the OSD itself, the Blue Store OSD, and then the cache is actually a write cache. So underneath, PetaSAN uses LVM to do the caching, so it has a nice write cache, and you can set that up on all of your OSDs. So it's very handy, and it's nice to have that little extra speed for your spinning disks. And we can see here our SSDs. You can see what they're being used as. So this SSD here is being used as a cache. This one here is being used as a journal, and so on. So pretty handy. And then adding a new OSD to the cluster is very, very simple. Once a new drive gets added into here, you would see it immediately, and you can then start adding it as an OSD. It's really nice and intuitive. So what we came to see, the iSCSI disks, let's take a look here. Okay, so let's take a look here at our iSCSI disks, and we can see here we've got quite a few of them. Not all of them are in active being tested, but they were just used for different demos or different demonstrations and configurations in the lab. But let's just take a look at the first one here. We can see it gets an ID. You configure the size for it. You give it a name. It tells you when it was created, what pool it belongs to. Now we can see here that we have our IQN, but each disk in the cluster, so each iSCSI LUN actually gets its own IQN with its own ID attached to it. And then we take a look at our paths. If we click on it, we can see the active paths. So we can see this this VMware 1 has 2 paths. The first one is running on PetaSAN 1. The second one's running on PetaSAN 2. And we can see we have it one IP from each subnet. And that's going to go like that throughout the entire thing, which is really nice. And if we want to click on Add iSCSI Disk, I'll show you what that looks like. Very intuitive. So we give it a name, and then you either use this to decide how big you want it, or you can just type it in manually if you'd like to. Then from there, if you're just using the regular replicated RBD pool, this is all you need to do. Select the pool that you're using. Define if you want to use 2 or more paths, if you want to use both subnets, which you typically should, and then also if you want it to automatically assign IP addresses, you can. And if you don't and you want to give them yourself, you can do that as well. Final thing here, if you're using password authentication, you would configure that here. So if you're using CHAP, if you want specific clients that can use this and no other, you would configure that here. And then finally, if you have that mirrored cluster on a secondary site and you want to enable replication for this RBD, so you want to be able to replicate this block device to another cluster for disaster recovery, you would select yes, and then you would set up a schedule for replication. So very simple, very intuitive. Now I am going to go more into iSCSI. Actually, let's take a look at path assignment as well. So this is really cool. You can take a look at how the paths are assigned throughout the cluster. And then if one of these nodes fails, so let's say node 3 failed, all of the paths that exist on this are going to fail over to one of the 2 remaining nodes. Now when that third node comes back up online and you get your cluster back to a healthy state, what you can do then is you can reassign the paths, and you don't have to do that manually. It's really cool. You can click reassign paths, you select automatic, and then you select distribute by path count, and PetaSAN will actually go one by one and distribute the load evenly throughout all the nodes. So it's really nice in that regard to get your cluster back to as evenly configured as possible. So if we're doing Cephs or Samba, this is where you would have your Ceph share. So we can see we've just got one test share up and running. If you want to add it to your Active Directory, you can do that in your configuration. And then NFS as well. If you want to have any NFS exports, you would do that here, but we don't have that configured. Another couple little cool things before we finish up. It does have its own built-in cluster benchmark that you can do. It's good for local testing as you're doing your testing across all of the chain, or all of the nodes in the chain of your configuration. It's good to do local testing first to make sure that everything is running correctly on the cluster itself before you start to go and test things that are outside of the cluster and performance on like client devices. So it's a nice, easy, handy benchmark built into the dashboard, and it'll give you all the output here, which is really nice. You can do it through command line as well, and you'll have much more fine, granular changing, being able to do custom benchmarks in that, but this one's really nice just to do a quick benchmark, make sure everything's running correctly. Finally, we can take a look at our cluster maintenance. So this is going to be familiar to anyone with knowledge of regular Ceph, Red Hat Ceph, and you can see here we have our OSD settings. So in the event, let's say we have to take a node down for maintenance, and we don't want the cluster to begin self-healing and rebuilding that data on the remaining nodes because the maintenance is only going to last for an hour or two. Well, we would come in here and we'd set off no rebalance, no backfill on our cluster, and no out, and make sure that Ceph doesn't move that data while the node is down for maintenance. And this is very similar to the way it's configured in regular Red Hat Ceph as well. So, and then final, it's fencing as well. So this is a different configuration that is sort of new, or only specific to PetaSAN, and it has fencing involved. So if the nodes can't communicate for a set amount of time, it will shut down that node, and that's typically for the SAN aspect of the cluster. It does that so it'll push the paths of the iSCSI LUNs over to the nodes that are communicating, that are working. So you can turn that off if you would like to, but it is recommended to keep it on. Okay, so now let's just show a little bit about the configuration with the vSphere side. So we have a vSphere cluster here up and running, and what I'm going to do is just show exactly how we configure this with Iscsi. So there is a few specific things that we do a little bit differently, and that's just what I'm going to show. So if we click on one of our 3 nodes here, and we click on storage adapters, and let's get a look at the properties here. So first and foremost, we can see we have a few different PetaSAN LUNs here that are connected. And we look at our paths here, we'll see right away there's something a little different where you have multiple paths to each LUN, but everything is active. So by default, vSphere and ESXi VMware will use last recently used, or least recently used. Actually, if we click here now, we can take a look at that on our PetaSAN disk. So if we click multipathing, we'll see here we have it configured to round robin, but what VMware uses by default is most recently used. Sorry, I used the wrong term. So that's what they use by default, and it will just use the last recently used path, and then if that path fails, it will fail over to the second path. What we use with PetaSAN is round robin, and then also as a added difference as well, we change the IOPS from 1,000, which is by default. So that means every 1,000 IOPS, it will switch to the other path by default. What we do as a special configuration, and actually I can move on to one of these nodes to show it, is we set 1 IOP. 21. Oh, wrong IP, of course. And so that's one of the only big changes. There are a few others, but we might keep those as a special little sauce that we have for behind the scenes. We may release them someday on another video, but I think we'll keep that for now. But this is the main one that is going to give a whole lot of extra performance on your iSCSI LUNs. So we can take a look here. We can see our, actually let me clear this and do that one more time. So we can see we have our PetaSAN disks, and we can see the policy is set up as round robin. And the policy for IOPS is 1. So by default, if you did this, you would see it's changed to 1,000. So that's the big change that we make on our iSCSI paths. And so each time 1 IOP is sent down the path, it switches to the next side. So that actually allows for quite a bit better performance as well. So yeah, that is pretty much a good overview of how we configure our PetaSAN clusters and why we really like PetaSAN and the great iSCSI configuration that comes with it. Now, I may do some more videos about this in the future, and I did tease a little bit about benchmarking, but unfortunately that's not going to be able to be done this time because I have been doing a little bit of configuration on this PetaSAN and it's just not ready for benchmarking. But that leaves me as for a perfect video in the future where I can do some benchmarking and I can do some more in-depth tuning for iSCSI with multipathing as well as improving performance. So look out for that in the near future.
All right, so I hope you enjoyed that run through of PetaSAN. If you find it interesting and you want to know more about it, we'll leave a link in the description for the PetaSAN website. Also, since it's open source and free, anyone can download and try it. And another really cool thing is they have an active forum on their website, and they are very active on there. The admin is always on answering questions from users. You don't have to pay anything for it, and they're very, very helpful. So take a look, and we'll see you on the next one.